Welcome to The Explainer. Today we're diving into a seriously fascinating leap in wearable tech. Forget your standard smartwatches or fitness trackers that just hoard data. We're stepping into the world of fabrics that literally process information just like a biological human brain. Yeah, we're talking about spiking neural networks, or SNNs. This isn't just some minor upgrade, guys. It is the definitive AI model driving the entire next generation of smart textiles. So I want you to ask yourself a pretty wild question. What if your clothes could think like a brain? I mean it. Try to shift your mindset away from rigid, clunky accessories strapped to your wrist and picture intelligent, autonomous garments. Clothes that don't just sit there looking good, but actively sense, compute, and adapt to your body and your environment in real time, right there on the fabric itself. Section 1. The next generation of wearables. Let's get right into it.
You see, traditional artificial intelligence, like the complex neural networks we use today, relies heavily on continuous data sampling. They're constantly recording, constantly pulling high-precision data frames, and then shipping it all off to some centralized cloud server to be processed. And man, is it battery draining. Think of it like a security guard, staring unblinkingly at a totally empty hallway 24 hours a day, 7 days a week. It takes a massive amount of energy to keep that up. But spiking neural networks, they are fundamentally different. They're event-driven, operating with these really sparse activity patterns. They process information locally, right on the edge, which in this case is literally your shirt. To go back to our analogy, SNNs are kind of like a highly efficient motion sensor. They only activate, or spike, when someone actually walks by.
Moving to Section 2, meet spiking neural networks.
So, what exactly is a spiking neural network? Well, it's often called the third generation of neural networks. It's an AI model that's directly inspired by the biophysics of our very own human nervous system. Instead of constantly crunching continuous mathematical activations, an SNN processes data through discrete spikes. Basically, the network's artificial neurons just sit quietly until an event, maybe a sudden touch or a quick spike in your body temperature, pushes their potential past a specific threshold, and only then do they fire. This asynchronous, threshold-based setup is absolutely crucial. It's exactly why SNNs are the secret sauce to bringing AI directly into our clothing.
The biological inspiration here is just spot on. You can see how the biological Hodgkin and Huxley neuron model maps directly over to an artificial circuit. The actual biological resting and action potentials, the ones governed by potassium and sodium channels in our bodies, are visually translated right into an artificial circuit made of capacitors and variable resistors. Engineers are literally out there building electronic components that perfectly replicate how our biological neurons and synapses process information. It's wild.
And the crucial takeaway here is event-driven intelligence. Because SNNs process these asynchronous event streams directly, you don't need any expensive, battery-draining frame reconstruction or heavy post-processing. You just get instant action. This leads to orders of magnitude reductions in energy consumption compared to traditional AI. And let's be real, when you're dealing with a power source tiny enough to weave into a piece of clothing, this immense energy efficiency totally validates SNNs as the definitive model for smart textiles. Section 3. Building brains into fabric. Now, when you actually translate a neural network into a multi-layered physical fabric, the architecture is just stunning. In a 2D woven fabric neural network, the threads themselves act as the interconnections, or synapses. You've got layer 3 down at the bottom serving as the input layer, woven with actual textile sensors. Then the middle layer acts as the hidden neural network layer, where all those artificial neural nodes are interconnected. And finally, layer 1 right on top is the output layer, which gives visual alerts or feedback. So it is quite literally a brain embedded right into the warp and weft of the fabric. Let's walk through how data actually flows across this textile. It happens in 3 distinct phases. First up, the input layer acquires data. Say a physical touch or a sudden change in strain is detected by advanced multimaterial fibers in your sleeve. That tactile stimulus is immediately converted into a spike. Next, that spike travels to the hidden layer, where the fabric SNN processes the event, altering synaptic weights and recognizing the pattern instantly. And third, the output layer triggers an intelligent on-garment response. It could be notifying the wearer of an anomaly, and get this, it does it without a single byte of data ever needing to travel to an external cloud server.
All right, Section 4, the wearable microbrain.
Researchers Cleary and colleagues have this amazing vision. They picture, quote, a world where the very fabric of our garments possesses a level of seamless, inbuilt sensing and AI. This captures the ultimate goal of their wearable microbrain prototype perfectly.
They foresee a future where you can actually purchase interchangeable, modular fabric AI patches, so you could swap out these hidden fabric layers to personalize, upgrade, or enhance the edge processing capabilities of your smart garment, completely customizing what it can do. And remember, the crucial thing here is that these aren't just microchips glued onto a shirt. The SNN AI literally is the fabric.
But our clothes go through a lot. They're washed, stretched, torn, you name it. Well, the wearable microbrain was tested extensively for surviving the elements. Because of its distributed neural node design, it's got incredibly high fault tolerance. Researchers subjected the prototype to severe physical ripping and fraying, and incredibly, the garment remained fully functional even after they purposefully disconnected specific neural node patches 5 and 8 to be exact. The network just adapted. I mean, try doing that with your smartwatch. It really highlights the incredible resilience of building intelligence directly into the physical structure of a fabric. This brings us to Section 5, Changing Healthcare and Beyond.
Okay, so why does all this matter? Well, this technology has massive life-saving potential. By integrating real-time health monitoring via fabric SNNs, we can dramatically change the game for remote patient care. Just imagine garments providing continuous cancer care monitoring, instantly processing physiological signals to detect any deterioration. Or cardiovascular alerts and neurological disorder tracking, where the AI decodes complex biosignals and catches critical health concerns the exact millisecond they happen, completely independently of a smartphone or a Wi-Fi connection. We're even seeing haptic smart sleeves that can actually classify complex touch sensations in real time. It's a real game changer.
Now, prepare to have your mind blown by this number, 11 seconds. During testing, researchers pulled off something truly profound. They successfully interfaced the wearable microbrain prototype directly with live biological neurons. Using just the textile pressure sensors on the surface of the smart garment, they managed to trigger an action that stimulated a biological brain slice. And they maintained that stimulation for a full 11 seconds. Just wow.
This staggering breakthrough is officially ushering in a new era known as the Internet of Bio-Nano Things. We are witnessing the very early stages of a world where cybersystems, artificial textile intelligence, and living biological neural cells can literally communicate and interface seamlessly. It bridges the gap between the clothes we wear and the biology that keeps us alive. Honestly, it's the ultimate proof that spiking neural networks are the singular foundational AI model required to bring this next generation of smart textiles to life.
So I'm going to leave you with this final thought. As spiking neural networks move out of the lab and into the literal threads of our clothing, the boundary between human and machine is getting beautifully blurred. How would your daily life change if your wardrobe didn't just cover you, but actively and intelligently watched out for your health? Think about that. Thank you so much for joining me for this explainer, and I hope you walk away looking at your closet in a completely different light. See you next time.